Hello, my name is Patrick Sano. This is my submission for the JavaScript, module one JavaScript module. For this project, I decided to build a backend data analysis tool using Node.js. Instead of a traditional web page, I want to focus on the JavaScript handle that handles um, synchronous, that handles synchronous data processing and functional programming concept on the server-side environment. I can demonstrate how um, I can demonstrate how the code runs. So I'm gonna flip the camera. I'll just do this. So what I'll do, I got the terminal open here first. So we're gonna do node index.js. I'm executing this script by using the node runtime. So as you can see, the program starts. Let me give you a little bit more to see. As you can see, the program starts by initiating a fetch request. And it retrieves a list of user data that filters down the base of the criteria. In case the ID is less than 5, and it calculates the unique scores for each user using a recursive algorithm. Finally, the output is clean. It's cleanly to console. So here at the top, let's say let's walk through the code. I'm strictly adhering to ES6 standards here. First on line 17 here. Line 17, I importing the Accesses library. I chose Accesses to native fetch API because it handles the JSON parsings automatically and simplifies errors and handling the node environments. I also included a helper function to format the output. And here is separates my presentation from logic, from my business logic, ensuring my console output remains readable and consistent. We're going to scroll down to here in line 41, recursive factorials. One unique requirement is the module was to implement the recursion. I achieved this with the recursive factorial function. My goal here is to take the user ID and calculate the factorial to generate a score. The basic here is n is 0 or 1, and we return 1 to prevent the stack overflow. Otherwise, the function calls itself multiplying n and result in -1. So you can see that here. I chose recursion because it breaks and demonstrates how JavaScript function can act as independent units of logic, breaking larger mathematical problems down to smaller repeatable steps. And so here we scroll down to moving to the main execution flow. I wrap the entire logic as an async function. This allows me to use await words on line 66 here. When calling APIs to ensure that the code pauses executing until the data actually arrives from the internet, preventing race conditions. Once I have the data, I use a native ES6 array method to process it. I use the filter and then the map. This approach, chaining functional methods like mapping and filtering, is much cleaner and less error prone using traditional for loops. Then we're going to scroll down here. We're going to go to the, scroll down finally to like the catch block error. See that. So here in the catch block error, using the try catch block, if an API goes down or the network fails, a program catches it, exception and prints a user-friendly error message rather than crashing the entire application. Which like you really have to take into account that like, look, right, I mean, when like something crashes, it can get all in your head about it, and like you think that you did something so wrong. It could be a simple issue as the network, and so that's why that's what I did for this first one. I worked on JavaScript last semester a lot, and so I just thought I'd at least start with something a little bit more familiar. But thank you guys.